Welcome, my dear students, to lecture 5 of CS 302 Data Structures. I'm Dr. Sangeeta Bhattacharya, and today we are going to start with a very important data structure other than array, which is known as linked list. At first, linked lists are having various types. So at first, we are going to discuss about a single linked list, and then subsequently we will be coming to double linked list and circular linked list. So what is linked list? So imagine you are seeing a train, the local train or any kind of train, and just think how it is connected. So first there is an engine. So this is the engine part. And then it is connected to the first compartment or the first bogie. This bogie is connected to the next bogie, and this process is repeated until we reach the last bogie or the compartment, and this doesn't have anything after this. So this is the end. So this linked list you can also imagine to be somewhat like a train. What is it? It is some ordered collection of similar data items. Now, what is similar data items? So like array, so similar data items means either it will be consisting of some integer type of data, or it will be consisting of some float type of data, or it will be consisting of some char type of data, or basic primitive data type or primitive data structure, whatever. And so it's an ordered collection. Why the order? Order is because of this relationship. So there is this order in which the items are inserted into a linked list or deleted. So that's why we talk about these two terms, linked and list. So list is this list of items, and linked because there is a connection between each of the nodes. It's a linear data structure like array. So if we have to access any element, so it can be done in a sequential manner. Now let us know about the terms which is associated with a linked list. This is the chart. Now each of this is known as a node. So this is known as a node. So I will be just drawing our array here. So this is the array part of this particular example, what you can see. So we can contrast between the two, how it is different. So this is 4, this is 5, this is 6, and this is 7. And this index is 0. This is 1. This index is 2. This index is 3. This index is 4. And this index is 5. So these are the, and this is 6. So these are the 7 elements in the array, and the addresses will be something like 200, 204, 208, 212, 216, 220, and 224. Okay. Now, if we look at this linked list, so this is known as a node. Each node consists of two parts. One is the data element. So this is the data element of the data item. And this part is the other part is a pointer to the next node. A pointer to the next node. So this is a pointer to the next. So two parts, one is a data item. So this is one, and pointer to the next node. So this part is the pointer part, which is to the next node. That means this part contains the address of the next node. If you see this too, array does not require this part because in case of array, the items are stored in consecutive memory location. So if we know the base address, we can easily find out the addresses of the other nodes. Last class we have seen how we can do that using row major representation and column major representation. But this is required in case of a linked list, because in case of linked list, the elements are not stored in continuous memory location. Now, if we talk about the memory representation of linked list, then this is the start node. So this is my start node or the head node. The head node contains the address of the first node in the linked list. So if we see, this is the start node which contains the address. So this is some sequential. Let us think of it as the addresses. Let us think of this 1 to 10 to be the addresses. And H is the first data item. So let me draw this. So this is the head node or the start node. The start node contains the address of the first node in the linked list. So what is the first address? The first address is 1. This node, now remember the start node contains, it's only a pointer. It cannot be called as a node, but still we are referring to it like a node. But in the start node, the data part is empty and the pointer part is present. So this is basically a pointer. In the first node of the linked list, so this is the value data item H, and it is a pointer to the next node. Now, pointer to the next node means if we draw it like this, then what is that part? So we go to 4. In 4 it is E. So this is after H comes E. After E comes L. After L comes again L, as you can see. And after L comes O. Because this is the order in which the data has been inserted into the linked list. And now, what does the pointer part? So each node has two parts, data item part and pointer part. So what is stored in the pointer part of the last node in the linked list, that will be a null value. So that is means a null pointer. So here also you can see the same thing. When we write a cross, that means it is a null pointer. So this is null. Null. That means it is not referring to anywhere. So it's a null pointer. So this is how it is stored in the memory. So if we are inserting data like this into the linked list, the memory representation will be like this. Now, actually how the pointer is implemented, you know that, you already know that pointer means a variable which stores the address of another variable. So internally it will be like this. So this is H, and in this particular node, the pointer part will store the address of the next node, which is 4. You can see from here. So this is 4. Then in E, the node containing E, the pointer part will contain the address of L. So this is 7. Then in the L node, the pointer part will contain the address of the next value L, which is 8. And in case of this L, it will be containing the address of O, which is 10. And at last, if we are talking about O, so it will be a null value. So there will be nothing here. Now, as you can see, if we contrast this with the help of array, So this is, if we want to store, so you can see that this number, this is a character linked list. So I told it is a collection of similar data items. So this is a character linked list. And if we contrast this with the help of array, so the array storage will be like this: H, E, in a sequential manner, one after the other it will be stored. Hello. But here you can see the memory addresses are not continuous in nature. So it is anywhere in the memory, the variables of linked list can be stored. But in case of array, it will always be continuous. So if H is stored in 200, then E will be definitely stored in 204. So this is the difference between linked list and the array. In case of array, it is completely sequential in nature, in continuous in nature. While in case of linked list, it is dynamic in nature. Having said that, let us go and find out the difference between, let us go and find, I will go and explain the difference between array and linked list. Let us see that. So this is the difference between array and linked list. First is in terms of access. So I will be having the same example of linked list and array. So let me draw that. So this is array. So H, E, L, L, O, and so this is index 0. This is index 1. This is index 2. This is index 3. And this is index 4. Now, if I draw the same thing using a linked list, so this is H, this is E, this is L, L, and O. Now, let us see what is the difference between array and linked list in terms of access. And definitely there will be a head node or a start node which contains the address of the first node in the linked list. Now, in case of array, we can have a random access of memory. The access can be random in nature. What does that mean? It means that if we want to access a particular element of this array, suppose A4, we can do that without going through the whole list. So this is possible. Now, if we go to the, in case of linked list, the access is sequential. What does that mean? So the address access will be sequential. What does that mean? It means that if we want to reach L here, if we want to reach L in this, suppose we want to reach O in this linked list, so we have to start from the start node, visit the H node, next we have to visit the E node, next we have to visit the L node, again the L node, and then only we can access O. So this is what mean as sequential. That means for accessing a particular element of a linked list, you have to visit all the nodes before it. While in case of array, you can directly access any of the element of the array with the help of the indices. So this is the first difference between the array and the linked list. In the second, this I have already told. In case of array, it is continuous memory location. So array is continuous. Well, in case of linked list is random. Linked list is random. Random in the sense that it can be allocated, the elements of the linked list can be allocated memory space anywhere in the memory. Now, if we talk about the insertion and deletion, in case of array, if we see, then in case of array, the insertion and deletion consumes more time. Insertion and deletion consumes more time. Why? The reason is that if we want to insert an element after O, first of all, if we are doing it statically, then in case of static array, we have to rerun the loop. And the fact is that if you want to insert any element after O, you have to do it, you have to visit all the elements of this array till O, and then only you can insert an element here, suppose X. But in case of linked list, the advantage is that we will be seeing these algorithms. In case of linked list, insertion and deletion is easy because we will be seeing that with the help of the algorithms, and then it will be more clear that we can do this anywhere. It's easy because it can be done anywhere. We can do it anywhere. And thus, it is faster than linked list. We can, in case of array, in case of linked list, we will see that we can insert an element either at the beginning of the list, or we can insert it at the end of the list, or we can insert it anywhere in the middle. Anywhere in the middle. So we can also insert an element X here. We can also insert it here, or we can insert it here, or we can insert it here. Similarly, if we want to delete an element, we can delete it from anywhere in the list, from the beginning, end, or from the middle. Well, in case of array, the insertion and deletion both has to be done. Insertion has to be done only at the end of the array. You cannot do it in the middle. And deletion doesn't actually delete the element from the array because it only empties it. That means if we want to delete, this space is only empty, but this space is still occupied by the array. It is actually not given back to the computer system. The array A still holds it when you are running the program. But if we delete a node from a linked list, it is actually given back to the computer system who can use it for it is actually given back to the memory, computer system memory, where it can be used later on for some other program. Now, in case of allocation of memory, one thing which is different between these two is that, so in case of array elements are stored in the stack section. In case of array, you just remember this point because till now we haven't gone through what is stack and what is the other points. But you remember that when an array is allocated memory, it is allocated in the stack portion of the memory, and in case of linked list, it is done in the heap portion of the, so heap section in case of linked list. This is the difference between the two. We will be looking at what is heap and everything in the subsequent classes. But you should remember that in case of array, the memory is allocated in the stack section, while in case of linked list, it is allocated in the heap section. Having told you these things, now let us go and check what will be the complexities, what will be the complexities of the insertion and all the other operations which we can do on linked list. Now we are coming to the algorithms for insertion and deletion. But before that, let me tell you something. Why array is known as the ADT or abstract data type? Because that is important. I told that while going through the class, I will be telling you why each of what are ADT and why each of the data structures are known as ADT. So why array is why linked list is known as an ADT? See, when we have to implement the linked list, we will be doing it in terms of this. So, struct node. Suppose I want to store integer data, so I will be writing int item. You can write it anything, variable name can be anything. And then struct node star ptr. What is this part? So this is known as a self-referential pointer. So this is known as a self-referential pointer. And what does this mean? It means that you have a structure node which contains two things. One is an item and the other is a pointer to itself. Why we are calling it like this? Because see, if this is a node, this node contains an item part. So I have written here int, it can be any kind of data type. And this will be containing a pointer. That means it will be storing the address of another similar kind of node. So this will be another item, maybe I1 we can write. So that's why this is known as a self-referential pointer, because it is going to store the address of another similar kind of node like itself. So when we implement linked list in a programming language, we declare a structure like this. Now the question is why structure? Because we know that structure is a data type, is a derived data type which can contain data of different types. So here we are considering two types of data. One is the integer data and the other is the struct node type data. So different type of data, that's why we are using a structure. And the other important point is why we are not using union in this case, because in case of union, what happens that a single memory space, whichever is larger, is allocated for the particular union variable. Now, if we do union here, then we don't know what is the size of int item. The int item will be 4 bytes. So the pointer variable will also be given 4 bytes. Now, if 4 bytes space is shared between item and the pointer, so if pointer is placed, then item will be removed or it will be deleted. Or if item is placed, the pointer information will be deleted. That's why we are not using union here. Instead, we are using a structure. So in the memory, for item, there will be a separate memory space. For pointer, there will be a separate memory space, which will not be possible if you are using a union here. Now, why linked list is known as ADT? See, when we will be looking at the, so let me first talk about the first algorithm which we are having, which is insertion. And once we tell that, I think it will be clear why linked list is known as a ADT. So this is the algorithm to print the number of nodes in a linked list. So let me draw a linked list, and that will be our reference for the remaining program. So let us have the same thing, hello. So this contains a pointer to the next node. So this contains a pointer to the next node. So E. So this will be L. Let us have only 3 elements in this array. So it's a character, linked list. So let us have only 3 elements in this linked list. Now, to print the number of nodes in a linked list. So we want to print how many number of nodes are there in the linked list. So first, set count equals to 0. Count is because it is going to count the number of nodes, so it is 0. Now ptr is a variable which is equals to start. So start, I told, is a pointer which is going to point. So say start is a pointer which is going to point to this node. So it's a pointer pointing to this node. ptr equals to start means ptr is again a pointer. If we assign the address stored in start to ptr, that means this is also going to point to the first node. So this is also going to point to the first node. So ptr is pointing to the first node. So start. So let me give the addresses also. So let this address be 200. Let this address be 200, 300, because it is not continuous. Let this address be 400, something. What is happening? Start contains 200. Okay. This part contains 300. This part contains 400. Okay. Because it is containing the address of the next node, and this part is nothing. So start is 200. So if start is equals to ptr is equals to start, that means ptr is also equals to 200. So ptr is also equals to 200. And if ptr is equals to 200, then ptr is also pointing to the first node. Then ptr is also pointing to the first node. Now repeat steps 4 and 5 while ptr is not equals to null. What does mean? So ptr is not equals to null. So initially ptr is 200. Is it null? No. So count is incremented by 1. And then ptr is equals to ptr arrow next. Now understand this point clearly. ptr is pointing to here, and ptr arrow next means this part. This part is referred to as the next. So what we have written it as struct node star ptr. So we can also write it as struct node. So I will rewrite that. So struct node int item struct node star next. Okay, struct node star next. That means this is the pointer referred to here. Now ptr equals to ptr arrow next means, so ptr is 200. What is there in ptr arrow next? So in ptr arrow next, now it becomes, what is the value here? 300. So now ptr becomes 300. Again, we will come back since it has been given repeat steps 4 and 5 until PTR is equals to null. So is PTR equals to null? No. So now PTR is pointing to this node. So this is PTR now. So now this is PTR. Count plus plus. So count was initially 1. Now it becomes 2. Next, again PTR is equals to PTR arrow next. So initially the value was 300, 200. Then we did PTR arrow next. PTR becomes 300. Now again we are doing PTR arrow next. So what is there in PTR arrow next? It is 400. So we just remove this part and it will become 400. Again, is PTR equals to null? No. So again we go inside. Now count plus 2, it becomes 3. PTR equals to PTR arrow next. Now what is there? So PTR now is pointing here. So it was pointing here. Now it is pointing where? After it becomes 400, it is pointing here. So this is PTR. Now, again we did PTR arrow next. PTR arrow next is what? Null. So this is no more 400, but this is null now. So what we put here? We put a null here. So null means nothing. So well, PTR not equals to null, but it has become null. So it will come out of the loop, print count, which is the value 3, and it will. Now, going through the whole algorithm, so here two things. Whenever you are writing an algorithm, you have to mention two things, which is not mentioned here. I will just write it down. One is the input. So what is the input here? The linked list. So you can call this, the input is the linked list L, and the output is what? Count of the number of nodes. So count of the number of nodes. So if we look at this, so this two you should always mention whenever you are writing an algorithm. So input is a linked list L and the output is a count of the number of nodes. Now, why the important question? I come back to the important question again. Why linked list is ADT? So why linked list is ADT? Now I hope you will be understanding that. See, when we have written the whole algorithm, nowhere we have mentioned the fact how the linked list will be implemented. When we are implementing this program using some programming language, nowhere throughout the whole program we have mentioned that what will be the implementation details of this list. We have written here list. How this list is going to be implemented, nowhere we have told that. So that's why it is known as a ADT, because in case of ADT, we are concerned only about what operations are allowed and we are not paying any attention to the implementation. So internally it may be implemented like this using a structure, but when we are writing the algorithm, we are not concerned about the implementation, and that's why linked list is known as a ADT. Now, my next question comes, because we have read the order notations now, and I have told that we are more concerned about the worst case scenario. That is, what will be the maximum time taken in the worst possible input sequence. So if we look at that, what will be the for printing this? What will be, so we will be, so this is printing the number of nodes. Now we will be looking at the mode. So this is like not operations. So it can be termed as accessing. Now, we will be looking after this, whatever we will be seeing. So if we are counting, so what is the worst, what will be the complexity in this case? It will be, I have writing order, this is big O, of n. Why? Because for counting the number of nodes, you have to start from the first node and reach till the last node. So if there are n number of nodes in this linked list, then we are going to visit each and every node for counting. That means if there are n number of nodes, I have to go for n times. This loop has to run till n times, and therefore the order will be O of n. So this is the worst case. And printing the number of nodes will always be order of n, because we have to count and print n number of nodes. Now let me go to the next one, that is searching an element. So searching an element, let me first remove this part. So we will be using this thing here. So I will be just keeping this because this is for our reference. So this will be there. So now I am moving to the next one. I am moving to the next algorithm of searching an element. Now, in case of searching an element, let us see first, in case of array, how we can do it. So I told searching an element means you have been given an element, you have been told about an element, and we are going to search for that element. And when I was explaining about this array searching, I told that it will be order of n. So let me have this. So h. So let me remove some part. So it will be same like our linked list. Whatever we are having in this linked list, we will be having the same kind of thing. So linked list is having 3 elements. So our array will also have 3 elements. So let me write H, E, M. And suppose the character which I want to search here is O. So you see, when is the best case arises? So in case of this, the best case will be if I'm searching for H. At the beginning itself, we are finding H, and it will be returning you a time in constant. But if it is not, if we are trying to find for n, we have to start from O in this index O and go till 2. That is, we have to go till n number, till from beginning of the array till the last. And in that case, what will be, how many times the loop will be running? The loop will be running for, so the loop will be running for n number of times, and in that case, the order will be order of n, because we are expressing it in terms of the input. So the input will be n number of elements, so it will be order of n. So in case of array, it is order of n. Now let us see what will it be in case of linked list. So see, again the same thing. So we have to, again here in this case, we will be having the same input. So the input will be the linked list So the input will be the linked list L, and the output, let me bring this here in this part so that and output will be success or fair or found or not found, because we are searching for an element, so found or not found, anyone. So the input will be the linked list and the output will be the found or not found. So what we are doing, so again we are starting from the start. So start is pointing to 200. PTR is equals to start means it is also pointing to 200. That is the first node. Again val PTR is not equals to null. Now this val is this value, whatever elements we are trying to search in the linked list. So val is that value. Now val is equals to PTR arrow data. So this I have written item. You can also write data here. So it depends on you what you are, how you are going to write. So this is data basically. So this part is the data. So val equals to PTR arrow data. So suppose we are trying to find for H. So is it equal? So this is the base scenario where we are searching for the first value in the linked list. Suppose we are trying to find for O. Val equals to PTR arrow data. If you are searching for H, then this position will be equals to PTR, that is this value, this address. We will go to state 5, that means it is N. If not, so if we are searching from O, suppose, then is it equals to PTR arrow data? No, because this is H and this is O. So we go to the else part. PTR is equals to PTR arrow next. So PTR was 200. Now it's equals to PTR arrow next means 300. So we make this 300. So now PTR is not pointing here. So whenever you remember that we are assigning any value to PTR, PTR will no longer point to that node, but it will start pointing to the next node, because that is what the address showed in PTR. Again, val equals to PTR arrow data. No, our value is O and here it is E. So again, PTR will be PTR arrow next. So instead of 300, it will be now 400. And PTR will no longer point here. PTR is going to point here, because that is what the value here. Again, val equals to PTR arrow data. No. So PTR equals to PTR arrow next. So what is there? Now it is no more 400, it is none. So PTR is basically not pointing anywhere now. So it is not pointing anywhere. So we have not found the element. Position is null, because initially it was null. So now also it is null, and we end. Now you see, in the worst case, in this case, in linked list also, in the worst case, it will be the odd, how many elements we have to go through or how many nodes. So in the worst case, when the element is the last element, when the element is the last element in the list, or the element is not present in the list, we have to visit all the n number of nodes. We have to visit all the n number of nodes in the list, and hence the complexity, so this is the complexity, will be order of So this is common. So in the worst case, we have to visit all the nodes. And in case we visit all the nodes, so we have to visit all the n number of nodes. And then it will be similar to the array and it will be order of. So this will be the complexity of this particular linked list. So in the next class, we will be seeing the insertion and the deletion algorithms. And at the same time, we are going to see what will be the complexity difference between an array and the linked list. Now, one important thing which needs to be told now, that why we are talking, so this is a single linked list. What is meant by a single linked list? So if I again draw it, we can see that, so this is our linked list. This is the linked list what we have seen now. And in this linked list, how many pointers are there? So there is only a single, so this is a start node hit. So how many number of pointers are here? So the number of pointers for each node is equals to 1. So the number of pointers for each node is equals to 1, and hence this type of linked list is known as a single linked list. And that's why this type of linked list is known as a single linked list. So this single or singly means that the number of pointers for each node is equals to 1. That is the pointer to the next. And that's why these are known as single linked list. So I hope this lecture, by this lecture, you are now clear why we are going to use linked list for most of the implementations. And next, what is the advantage of linked list over array? We will be seeing it more with the help of insertion and deletion in the next lecture. One more important thing is that in case of array, the implementation can be both static and dynamic. As you know, so array can be declared both statically, such as int a5. And in this case, what happens is that the memory will be allocated during compilation. Or we can also allocate it dynamically by using malloc or calloc function. So it can be done both dynamically and statically, but in case of linked list, we have only the dynamic. So in case of linked list, only the dynamic memory allocation option is available. It cannot be done statically, because you can understand by now that in case of linked list, the nodes are allocated during runtime. And in case of array, it can be both static and dynamic. So I hope this lecture is helpful for you. We will be seeing in the next lecture about the insertion and the deletion in single linked list, and along with that, the difference between array and linked list. Thank you very much.